Thank you everyone for attending our webinar on Morningstar's new Ethernet MeterBus Converter, the EMC-1. This is Mark McHenry along with Doug Grubbs, Morningstar's application engineer. And as we talk about the features and capabilities of the Ethernet MeterBus Converter, I invite you to text any questions in the chat box at the bottom of the GoToWebinar pane, and we'll address them at the end as time permits. Also, just a reminder, we're going to be providing all attendees a recorded version of this webinar. And so without any further ado, let's go ahead and take a look at the agenda for today and get started. Okay, so first we'll give a 30-second overview of who is Morningstar. Then we'll introduce the Ethernet MeterBus Converter, EMC-1. We'll talk about how to operate the EMC-1. Next, we'll cover how live view displays your data and how system settings can be modified in MS View. We'll discuss MODBUS Protocol and differentiate the EMC-1 versus other serial converters. And we'll end with a summary and answers to the questions that you submit to us in the GoToWebinar chat box. So who is Morningstar? Morningstar is a U.S. company. For more than 20 years, we've been a leading supplier of solar charge controllers and inverters, with the same ownership, management, and distribution partners since the beginning. Our customers gave us an A rating for product quality in this year's customer survey, and over 3 million Morningstar products have been supplied worldwide since our inception. So this Ethernet MeterBus Converter, or EMC-1 device, converts a serial connection to an Ethernet connection, enabling compatible Morningstar products to be connected to an IP network and the internet to facilitate remote monitoring and remote system settings adjustments from almost anywhere in the world. So you can see in the diagram here how connections are made with the RJ11 cord between the Morningstar product on the right and the EMC-1 in the middle here. And the EMC-1 is connected to an Ethernet gateway, which is typically a router or a switch that you see on the far left here. So, for example, many of you might have legacy Morningstar products that up until now could not connect to an IP network or internet. But now if you connect the Morningstar controller or inverter to the EMC-1, you can view remotely in your browser many useful system metrics such as battery voltage, PV current, load current, and faults or errors within the system. This information will appear live in real time, so you'll see data changing without having to refresh your browser. Also, you will now have writing privileges to change your battery charging settings, temperature settings, and low voltage disconnect settings, and also your lighting settings. And just to clarify what we're talking about in terms of RJ45 and RJ11 MeterBus port connections that you see here. Let's go to the next slide. So on top, you see here the RJ45 port that is used for Ethernet computer network cables, and then underneath it you see an example of the RJ11 ports for connecting telephone line jacks, for example. Here are the list of Morningstar products that are compatible with the EMC-1. You have the TriStar PWM, TriStar MPPT, ProStar MPPT, SunSaver MPPT, SunSaver Duo, and SureSign Inverter, and any future Morningstar products that feature a MeterBus RJ11 port. So it's important to note that this converter was designed to work with Morningstar products only, not other brands of controllers and inverters that might not have an RJ11 port, might not be MODBUS compatible or otherwise compatible. So Morningstar introduced remote communications on some of its products all the way back in 2003. So we have a lot of experience with remote communication capabilities. The big difference between the serial port remote communications in our earlier offerings and what we're talking about today with the EMC-1 is the EMC-1 converts a serial port to an Ethernet connection. Serial connections support only one device, while Ethernet supports many devices on a network. And in 2009, we launched the TriStar MPPT 60, which was enabled with Ethernet connectivity capability, and it's been very, very popular because of this feature. So now our other legacy products that we talked about on the previous slides, including smaller controllers, they'll now have this Ethernet connectivity feature when they are connected to the EMC-1. And our customers tell us that up to 30% of their solar power system inquiries request remote communications as a critical feature for the system they want to deploy. And we suspect this percentage will be much higher when installers and end users realize the advantages of remote communications in terms of troubleshooting and also technical support. And customers at industrial sites such as telecommunications, oil and gas, and security monitoring that involve very critical loads, they recognize the need for enhanced remote monitoring of their systems, especially when these systems are at sites that are not very easily accessible. And remote monitoring gives insights that help to establish longer lasting and more reliable systems. Remote monitoring has already become a requirement in some applications for successful operation and reliability in the field. Many Morningstar products adhere to the solar industry standard MODBUS communications protocol, and a little later in the presentation we'll go over why MODBUS compatibility among Morningstar products and the EMC is so important. And lastly, I just want to state that wireless network access has become more and more affordable as cellular infrastructure has developed, and wireless access to a variety of devices is what is driving the Internet of Things. So when the EMC-1 is used with a Morningstar controller or inverter, the Morningstar product is put into a serial communications mode. The controller can then be connected to any type of Ethernet connection. The controller itself actually includes an IP address. A common convention would be 192.168.1.100, and that IP address is assigned to that controller, and then it can be accessed on the network using a variety of software and or hardware. Some of the most common used hardware for these networks could be cellular connections, Wi-Fi, point-to-point private networks, or even satellite systems which are compatible with an IP address. The EMC-1 is powered by a combination of the MeterBus connection or a universal DC power input, or a combination of both. So you have a little bit of redundancy on the product. If one of those connections were to fail, the EMC-1 could fail over to the other connection. So let's talk a little bit about MODBUS Protocol. The reason MODBUS Protocol is used is because it's an open standard for industrial communications. It's a very simple and reliable interface. It's very important that the communication signals get through, especially for applications that are supporting critical loads. An important benefit of being an open protocol is that anyone can use it. It's not required to be licensed. It's not proprietary or available through only select vendors. It's an open standard that's published and can be used by anyone. MODBUS has also been recently designated by SunSpect as the underlying protocol for solar industry power communications. A lot of communications you see now for charge controllers and inverters and even large utility scale plants will use MODBUS for their protocol of choice. And MODBUS is also used by a variety of third-party industrial equipment. So PLCs, RTUs, and other types of equipment in SCADA, those can all utilize MODBUS, and there's a variety of software as well as MODBUS communication drivers that are available for programmers that want to work with this protocol. So you can see why we try to make this as easy as possible and build this into our products. MODBUS is widely recognized, cost-effective, and simpler than alternatives. So here are some of the technical specifications of the EMC-1 adapter, or converter, I should say. As you can see here, it has a very wide voltage and operating temperature range, so compatibility with the conditions at most any site will not be an issue. It has very low self-consumption, you see here, 2 watts maximum. Often it uses much less than that. It uses high-speed internet, small DIN rail mountable, and it only weighs about 1/4 pound. Now to go over some of the features on the EMC-1. First, you have a couple of dip switches. You can turn dip switch 1 on or off, depending if you want to write commands into MSView to change controller charge settings, for example. Otherwise, when this dip switch is in the off position, you will be in a read-only mode. And dip switch 2 enables a web monitoring service that will be available in late Q4. The default is the off position for both of these dip switches. And then number 2 is the Ethernet port that we talked about earlier. This allows you to connect the EMC-1 to a local area network or the internet. And then next to this port, you can see some small LEDs that indicate whether you have a good connection, good network connection. And then number 3 is the power input. This is the 8 to 80 volt input from battery power. Moving on to numbers 4, 5, and 6 that you see here. There are 3 LEDs right here, here, and here. And they'll indicate when the EMC-1 is powered on. A green LED will light up here when the EMC-1 is powered on. The LED above number 5 here indicates whether the future web service is on. And the LED above number 6 will turn green when dip switch 1 is on to allow Ethernet write commands. So the read-only status is unlocked, that you can see here, when the LED is green, so indicated you are in Ethernet write mode. Otherwise, it would be locked for security reasons in a read-only mode, and the LED would be off. And then let's take a look at number 7. This is the RJ11 MeterBus port we talked about earlier. It's on the right here. And this also allows bus power to the EMC-1. So this connection can provide data and power together. Some people have asked a question about when they need to use the power input shown at number 3 rather than just the MeterBus RJ11 connection for power. The power input connection is always needed. That's this one here. It's always needed for our TriStar MPPT and TriStar PWM controllers, whereas with other Morningstar products, you could use the MeterBus port by itself to supply power without also connecting the power input. But the most reliable connection to power is established when number 3 and number 7 are connected. And then one last point, a Y cable that comes with our EMC-1 is needed to connect our TriStar MPPT and TriStar PWM controllers from the RJ11 port on the EMC-1 to the RS-232 and RJ11 plugs on the controller. So we're looking at the network configuration here. You can see the network configurations here on the left. And we've got a very familiar scenario in terms of IP address configurations. This product is compatible with any IP network convention that's used. It's IP version 4. It's very easy to set up, or you can use the standard IP version it defaults to straight out of the box. There's another feature called NetBIOS that you see right here. A NetBIOS connection that you can use to locate your device on your network simply by typing in the product abbreviation followed by its serial number. So for the SunSaver MPPT, it's SSMPPT, and then the serial number. And that will automatically locate the device without even knowing the IP address on the network. It can give you the configuration screen. And as I said, it has a default IP address out of the box, but it's also set to use DHCP, which means it will ask for configuration options from a DHCP server if it finds one on the network. And that's typical of most devices of this type. We also give standard subnet DNS and gateway communication settings, as well as primary and secondary DNS. And this also is pretty typical of network-capable devices. So if you're using both the web interface or MODBUS communications, these are the standard listening ports in the industry. So we have 84 HTTP port and 502 for MODBUS. In most cases, these are left to the defaults that you see here, but for advanced users, you can change these ports if you need to do so and save it to the configuration. Otherwise, what you're seeing in all the boxes here on the left is pretty standard for anyone setting up a network. So what we're looking at here on this slide is Morningstar's graphical live view web page display that I alluded to earlier. And this has already been a feature on our TriStar MPPT product. But in this example, we've connected our ProStar MPPT to an EMC-1. And instantly, the EMC-1 will configure itself for a ProStar MPPT connection and gives you relevant data, including the array voltage. You also see the charge state, battery voltage, charge current, load state, load current, and any errors if there are any. And the nice thing about an HTML-based web page is that it can be displayed in a web browser on virtually any Windows or Mac computer, on a tablet or cell phone. These values update in real time without the need to refresh your browser. And depending which Morningstar product you connect to the EMC-1, each product has its own web page template to display its relevant metrics. So if we were connected to the Morningstar SunSaver Duo controller, we would see metrics for 2 batteries, whereas for the ProStar MPPT that we're seeing here, we see both charging and load control metrics. Also on the EMC web display, you will receive a graphical display of the product's logged daily values, including battery minimum and maximum. So you see battery minimum and maximum. You'll also see charging amp hours, charging stages, and if there's any faults or alarms, you'll see them as well. This display it's going to display values for as many days as the controller is capable of storing. So here you see the days up here going across. And in the case of our SunSaver MPPT, it would be 30 days. For the TriStar, it would be 90, and up to 256 days for our newest ProStar MPPT controller. And if you were to hover your mouse over the faults and alarms on an actual live view web page, you'd be able to see the specific fault or alarm that occurred that day, such as a short circuit or an over temperature alarm, for example. And if you want more detailed information, instead of using the web page, you can use Morningstar's MSU software, and you can connect directly to the device using the EMC-1 and get direct MODBUS data from the controller. And this gives you a much higher resolution view of the operating data within the controller. There are up to 30 system values that you can get from our products, and all these values will be updated in real time using a direct Modbus connection. And this MSView software is free, and it can be downloaded from our website. MSView can be run on Windows, and it can be emulated on a Mac. It can also be used to download the internal data logging file, which will be stored inside the controller, and then it can be saved to a local storage device and viewed as a CSV file. And lastly, if you're connected to the site remotely and you wish to upload a custom configuration, you can do so using the MS configuration tool. This will allow you to load new battery settings and network settings. So why would you use the EMC-1 versus other serial converters on the market? This is a very important question, so we wanted to cover why the EMC-1 is different than alternatives on the market that have to be configured manually. First, when you connect the EMC-1 to our products, it will automatically expect a Morningstar product, so it's going to communicate with the device and ask the device ID and automatically detect which controller it's connected to, and it will load the proper configuration options and website display data. It's going to configure itself to basically be an internet port on that product. Second, other serial converters on the market typically have RS-232 serial ports. Such a converter would require our MSC adapter to connect to the MeterBus RJ11 port. And additionally, not all of these RS-232 adapters will have the correct pin configuration as our controllers. And the EMC-1 has a very wide operating temperature range and conformal coding, so it's already designed to be used in harsh environments, whether they be Arctic, jungle, salty, or desert-like. The product is compatible with all the most common DC voltage ranges, including 12, 24, and 48 volt battery systems. And since we have an 8 to 80 volt input window, even if your voltage gets low, it will still power the EMC-1, or if your battery is being charged very high, the EMC-1 will still continue to communicate. The product is designed with a very low power consumption of 2 watts peak, and normally it consumes much less than that. The EMC-1 was built with a variety of off-grid solar applications in mind, using, or I should say, including telecom, security and monitoring, oil and gas, etc. And it's backed by Morningstar's support team, which has many years of experience in supporting our products in many different types of applications. And then lastly, the EMC actually generates the live view web page that we saw a couple of slides earlier, which you can't get with any third-party substitutes. We also have to clear up some information and go into a little bit more detail about Modbus compatibility. There are a lot of general use serial converters that will run on the internet, and some of them you'll run into these on the internet or see a lot of these general use serial converters, and they're going to make claims that they're going to convert serial communications to Ethernet. These converters are generally low price, and often their claims are too good to be true because they're often designed for a terminal server, like a generic text display that you see on older computers. So often what they do is emulate serial communications, but they don't treat the communications data with a lot of care. They just kind of stream the data over an Ethernet connection, and this might be okay with older devices, but not with newer ones. So it's important that your device is Modbus aware, because you have to maintain the integrity of the data connection you're making. Otherwise, you might find that you get a lot of errors and dropped communication packages, and in general, the product will not be very reliable. So the EMC-1 is fully compatible with MODBUS Protocol, and it ensures that it converts Modbus serial data to Modbus IP data in the correct manner down to the packet level. As an example, if you have a Modbus device and you connect a typical serial converter to it, you might find that what happens is when it converts the data into packets to send over the Ethernet connection, it does so in a very haphazard way. If these data packets are not aware of the Modbus data, you might find that it cuts off some data. And what this does is it wreaks havoc with the Modbus communication because it doesn't maintain the integrity. It basically chops off those packets into pieces that are no longer recognizable at the other end. So you might find that your communication system doesn't work, or that you're losing a lot of data and it's generally not a reliable connection. If you have a Modbus aware device such as our EMC-1, you'll find that it actually looks for the data packets that are coming in a Modbus format, and it will properly encapsulate them and send them over the Ethernet network. So then this way you'll have very reliable data transport from the device all the way to the other end of the network anywhere in the world. So all of this is very important to look out for. Also, as I mentioned before, the EMC-1 has a very wide input voltage range. You'll see a lot of devices on the market that are generally designed to be used with a wall transformer, sometimes called a wall wart. That's a cell phone charging type plug that will plug into the wall and give a fixed DC output. And that's because a lot of these devices are meant to be used indoors. In this case, a lot of these devices will come in set power ranges around 12, 24, and 48 volt batteries. So for example, 10 to 15 volts, 10 to 30 volts, or 36 to 72 volts on the higher side. But they're generally meant to be used with an AC connection and a DC power supply, not necessarily on a battery voltage, which could go up and down. For instance, 10 to 15 volts is not the widest voltage range. If your battery were to drop below 10 volts, there's a possibility that your device could lose power, which is not the most reliable situation to be in. So what you see with the EMC, the EMC-1, with that 8 to 80 volt range, we can go to extremely low voltages. So even in low power conditions, the device is still there to communicate, and we easily support the entire range up to 80 volts. So even a very high voltage 48 volt system bank can easily be compatible with the EMC-1, all from a single product model. Some additional features that we're coming out with. You see here the login page for our web service that is scheduled for release in late 2016. And we'll address this a little bit more on the next slide. So the web service will be available via a firmware update to the current product. And this will give some enhanced functionality to the EMC-1. With this service, instead of actually connecting to the device directly, the device will be set up to do a device-to-server transfer of data automatically to a cloud server. So this is going to function very similarly to the way that a lot of grid-connected inverters, web boxes will function as well. They connect to our controller. They regularly request data from the controller and upload it to a website. And then the data is stored there so that it can be more easily accessed and you don't have to connect to the site directly. The data gets published automatically. And in the cases of very large-scale deployments where you have a lot of sites, this is very well suited because it's really the best way to see all your data on one screen by connected to a web service. So the device sends data back to the cloud at regular intervals, and the site data is always updated at 15-minute intervals. This is a very scalable way to collect data from all the sites because you could have 1, 100, or even 1,000 devices all communicating back to this web server. And it has quite a bit of capability in storage, so that way you can log into a single point and see all of your managed sites in one location. The data is sent from the EMC-1. It's going to be encrypted, so it will allow you to transport that data securely and safely back to the cloud server. We'll be offering a variety of server-based notifications so that the server will give proper communications of the system status at the site. If you have a project with 1,000 deployment sites, it's not practical to connect to each site individually, and you really can't do that individually and see what's going on. You should let the sites notify you proactively if there's a problem. So that's what the web service will do. And lastly, we're going to give you organization tools to group the devices, systems, and sites with user-defined names so that you can manage the system very well and easily. Sum things up, the EMC-1 is the easiest way to enable advanced communications on Morningstar products. It's configured out of the box to communicate with our products and get configured automatically on a network, so it's very easy device to use. It has powerful communication options with MODBUS, with the website, and with our MSView software. It also features a very standardized power input that will work at almost any remote power site. Gives you the ability to unlock the existing data that was already being collected by our charge controllers and now making that data available on the internet. Most importantly, because it will work with any type of internet connection from cellular to Wi-Fi or even to satellite, it's very easy to get the connectivity you need at the site no matter where it's located or what the application is. Okay, so that concludes our presentation, and with that I'd like to open up the floor to questions and see if Doug here is on the line with us. If you can take yourself off mute and see if we can go to some of these questions. So Doug, are you there?
Hi Mark, I'm here.
All right, good to hear your voice, and let's take a look at what questions have come in.
Yeah, there's a few questions about our controllers. I can take those offline on email later today. So if you had a question about one of our controllers and its functionality that doesn't relate to the EMC, I can answer that on email.
Okay, gotcha. I see some of them. There's also a question that came in. It says, does this device only work with Morningstar controllers, or can it be used with others?
It would only be compatible with our controllers. It requires the MeterBus connection to work. So it would not work unless there is a Morningstar controller at the site with the MeterBus connection to the MeterBus port on an RJ11. And that would only be recognizing Morningstar products that are on the RJ11. So when you use the EMC-1, it's basically going to find that Morningstar product and be able to automatically be set up for Ethernet with that product, and that makes it easier to use with our products than you might find with other devices that are available.
Okay, very well. Thanks for the question, and thanks for the answer. Next question here. Does Morningstar have a recommendation for a brand model of routers or switches that will work with in an off-grid system and works with a cellular network?
Okay. Well, the connection to Ethernet is going to rely on your Ethernet connection. So when you make use a router, you can set up that router for port forwarding. So it will transmit either the MSView MODBUS port or the HTML port 80 for viewing live view. So you can do one or the other or both with routers. There may be some special setups required for your router with HTML. It may block that, or since it is HTML, and may I know my router required special settings and makes it, which I had to allow it to port forward port 80, which was different than the port for MSView and Modbus. So as far as getting a connection to cellular networks, that is possible. It will depend on how fast that connection is and if you have a good connection or not. So it's not going to automatically just work with any connection no matter how fast or slow. It's just like with cellular networks. You have to have data available. You have to have a good data connection fast enough in order for this to process and be able to read, either with either type of connection, with the HTML or the Modbus connection. It's going to have fast enough connection. So cellular, sometimes it'll work, sometimes it won't, but it should be able to work in many cases with cellular networks, especially with cellular networks getting faster these days.
Okay, very good. Thank you very much. Let's see, next question here is there a version with SNMP protocol?
We don't have SNMP configuration for the EMC-1 at this time. We should have it in the future, especially when we have the web service, and we will have that capability with that service. And now, when that will be available, I cannot say for sure. I think the service will be available before SNMP, but as you may be familiar with our TriStar MPBT, which has built-in Ethernet, and that does have up to 4 SNMP communication and notification options available. I'm not sure what the options will be when we introduce it for the EMC-1.
Okay, very good. We have some more questions that have come in. Let's see.
There was one from Tony here.
Let's see. Tony just typed in a question. Let's see. So the device will provide Modbus over TCP, as well as provide access to web GUI, just like the, I guess he's asking whether that's just like the TriStar MPBT. So he's asked a question, can I write software access the device via TCP Modbus? So can I write software access to the device via TCP Modbus?
Yes, you can get Modbus connection. It's basically the same as the MSView connection. With port 502 by default, you can change that port, I believe, and you would be able to use the same kind of software you would with our other controllers, whether it's a serial software, a Modbus program. You would be able to access the controllers through Modbus the same as you would with our serial connections or with the TriStar MPBT.
Okay, there's some questions about costs and pricing. We market through distributors, so we would have to refer you to a distributor to get your best pricing. There's some questions about also reselling this device, so we'll take care of those questions offline. Last question I see here is, can you connect to more than one controller at a time with this EMC-1?
Well, we have made a connection using the meter hub, actually. This would not include the TriStar and TriStar MPBT, though we're getting ready to test the TriStar and TriStar MPBT with a with using the RSC adapter, which would change the adapter from RS-232 to 485, but we have not tested this yet, so I'm not sure if that is capable yet with the TriStar and TriStar MPBT, but we have made a connection using our meter hub, which is a way of connecting to on a meter bus network to multiple controllers. So with the ProStar MPPT, the SunSaver MPPT, the SunSaver Duo, and the SureSign controller, I've made a connection to multiple devices using the meter hub accessory that we offer, and that would create a network, a MeterBus network, to be able to access the products that only have a MeterBus port with the RJ11 port. So all those, you can connect to multiple devices with the meter hub device.
Okay, very good. So it looks like we've addressed all the questions that we could online. I know there were, Doug, you mentioned there were, and I see them here, some questions that really pertain to our controllers, not to the MC, and we'll take care of them offline. But for now, I'm just going to go to the thank you slide and thank everyone for attending. I'll leave this up here for a few more seconds. If you need to go to MorningstarCorp.com and go to the Contact Us page if you want to contact us directly. And I'm going to leave this webinar open just for a few more seconds if you have any, if you're finishing up any other questions that you might have for us, any of the questions that we weren't able to answer, we will get back to you individually. So thanks, Doug, and thanks for everyone who attended. We'll see you next time. This concludes the broadcast.